Hello, everybody, and welcome back to Mr. Eichler's math class. I am Mr. Eichler, and this is part 2 in the beginning of our geometry unit. And today we are going to discuss angles and give some more vocabulary terms out, okay? So I'm going to go down on the corner here. See what I did there with the corner and the... never mind. Angles. As we learned, when two lines cross, they make an intersection. But they also make angles. An angle refers to how the lines meet up and the distance between the lines. If you look at the face of a clock, it measures the time by the position of the hands. And if we look at the clock hands, the hands of the clock, I can read, we can see that they also make angles. We can look at the clock and see that it's divided up into minutes and into hours, right? Because there's little tick marks in between the hours, and that all adds up to minutes, and so on and so forth. This circle is also divided up, but not in minutes or hours. It is divided up in degrees, not Fahrenheit, not a temperature degree, but a degree around the circle. A clock has 12 hours, but a circle has 360 degrees. Our circle starts at the top, it's 0. This is 12 o'clock. At 3 o'clock, where the 3 would be, we have 90 degrees. At the bottom, where 6 o'clock would be, we have 180 degrees. And over here, where 9 o'clock would be, we have 270 degrees. Now, if you think about the math here, when we go all the way around the circle, that's 360 degrees. What's half of 360? 180, right? What's half of 180? 90. Very good. And what's 90 plus 180? 270. See? It all adds up. These lines form our first angle. When we look at an angle, we measure it from the top point to the middle to the other end. And this angle right here is a right angle. The measure of a right angle is a perfect 90 degrees, like the corner of a square. A perfect 90 degrees, meaning only 90 and just 90. Can't be 91, can't be 89, can't even be 90.2. Got to be 90 degrees. This little red line that you see here, this is a mark that you can make on an angle that shows that it is in fact a right angle. It shows that it makes a square. So for those of us with slightly shaky handwriting and kind of make little squiggly lines, we can show by going in the opposite direction there that the line we've just made, the angle we've just made, is in fact a right angle for what we're trying to demonstrate. This square has 4 right angles, and that's what makes a square a square. We'll get that tomorrow. When an angle measures 89 degrees or less, it is called an acute angle. This angle measures 45 degrees. What's half of 90? That's right, 45. See, you guys are good. And this is halfway in between the 90 and the 0, so this measures 45 degrees. From here to here is 45 degrees. From here to here is 45 degrees. Coincidence? No, that's math. True story. Oh, look! Everybody in class today said that my dancing baby was creepy. That hurt my feelings. He's a cute little baby. He is. And look. Oh, what a cute little angle. Okay, when you think about acute, think about little. Okay, a cute little baby, a cute little angle. And this is a way that you can help to remember that an acute angle is a small angle, like my little baby. And a note of trivia here, because it's worth mentioning, this little dancing baby is actually the first example of something going viral on the internet. This was the first viral video back in early 2000. It was all the rage. Everybody had to have the dancing baby, and we all stood around everybody's computer and staring at the dancing baby going, wow, isn't that neat? Yeah, what little did we know, right? So, when an angle measures between 91 and 79 degrees, it's called an obtuse angle. Don't be obtuse. This obtuse angle measures 135 degrees. Okay? What's 45 plus 90? See, you guys are good, 135. And this measures 135 degrees from here all the way down to here. Whoa. And they said the baby was creepy. Okay, this man is obtuse. This man is obese. I can read. This angle is obtuse. Hi. And this is how we can perhaps remember that an obtuse angle is bigger than 90 degrees. Right? Right. Of course we'll remember all of that. This angle measures a perfect 180 degrees, much like the 90-degree angle. It can only be 180 degrees and just 180 degrees. This is called a straight angle. Now again, the two lines here are kind of meeting in a head-on collision. The center point is where the two lines meet. Okay? And so we have one line segment here, one line segment here. They are straight across and they create a straight angle. Just like the hands on this clock. Look, it's 3:45. Our next section is on rotation. And to quote the great bard's Rat from the 1980s hair band, round and round, what comes around goes around. And of course, this is a circle. Now, the degrees of a circle can also measure rotation. Rotation is when you spin around, right? Who knew? This is rotation, much like the way this little line is going to spin around our circle here. Okay? Meaning that an object changes its position, but it does not change its size or its shape. It just kind of moves around a little bit, okay? In a rotation, an object is turned about a center point through a particular angle. Now, this point here represents the center of this line, and it is on this point or axis that this line will spin. Okay? We can have, random skateboard people skating down the street and going, dude, I just did a 360, man. Awesome, dude. What are they talking about? They're talking about this. It simply means they jumped up in the air and they spun around in a complete circle, landing in the same direction that they were going originally. A 360, who knew? And if they do a 720, what's 360 plus 360? It means they go around 2 times, right? In a rotation, the object changes its orientation from top and bottom. So if we look at this line here, it was up top, but now it is down below. How far did it move? Moved 180 degrees, right? Depending on the location of the center of rotation, the object may also change location. Watch, we're going to rotate here now. So the whole object's going to move from this point at the bottom, just like the little fuel gauge on the car. For example, rotation. This triangle is going to turn 1/4 of a full rotation. In other words, it's going to turn 90 degrees. You ready? Hold on. I know. You're impressed. This is a 90-degree rotation. Started at 0, and it went down to the 90-degree mark. This triangle is going to make a half of a full rotation, or 180 degrees. So we're going to start at 0, and we're going to go all the way down here to the bottom. That's a 180-degree rotation. This triangle is going to make a 3/4 of a full rotation, or a 270-degree rotation. It'll start here at 0, all the way around to the 270 mark. And finally, a full rotation, or 360 degrees. All right, the difference between 0-degree rotation and a 360-degree rotation is this. Here is a 0-degree rotation. Ready? Go. Okay, it started at 0, it ended at 0. It didn't move. A 360 starts at 0, ends at 0, but it goes all the way around, making a full turn. That is a 360-degree rotation. That's all we got, folks. Again, please look for the note cards, flashcards down below. And as always, have a great night. Study hard. Bye.